The deep sea is often thought of as a barren, sandy place, pretty void of life. But it couldn't be further from the truth. Scattered all over the abyssal plain are pockets of life, from hydrothermal vents to whale falls to my favorite deep sea phenomenon, brine pools. These pools are a fascinating source for life. With the stark contrast between the deadly pools themselves and the life that teems around them, it almost seems alien in nature. Brine pools are an oasis of life in the abyssal plains of the sea, providing support for not only the ecosystems that surround them, but they potentially hold the answers for history, cancer, and even alien life. First and foremost, we need to define what is a brine pool. Brine pools are incredibly salty, and therefore dense, water that exists in basins at the bottom of the seas. More specifically, they can be found in the benthic regions of the ocean, in the abyssal, which is roughly 9,000 to 21,000 feet below the water, and hadal zones, which is everything below the abyssal zone. These pools have been found in the Gulf of Mexico, the Mediterranean Sea, and more recently, in the Red Sea. Because the density is thicker than that of the normal water, brine pools look and flow almost like water within water. Nearly all life that enters it is not soon to emerge either, as there's no oxygen in these pools. This means that when the fish swim down or crabs slip into the brine, they begin to breathe the oxygenless water and ultimately suffocate and die. However, life exists around the brine pools in abundance. In order to understand why there's an entire ecosystem around brine pools, you have to understand how they formed. According to Natural World Facts in 2022, brine pools are major salt deposits that were created when a portion of the ocean or sea completely dried up, leaving behind all of its salt. Layers of sediment then covered the deposit until it was completely buried, and then the ocean came back in and covered that sediment. Over time, salt tectonics, or the movement of sediment due to salt, caused the sedimentary layers on top of the deposit to shift and crack, allowing the ocean water to enter into the deposit. This water then floats upwards from the deposit and settles into a basin, thus forming the brine pool. When the salt leaves the earth where it's been trapped, chemicals from the earth's crust get released into the normal water with the brine. Because of this, chemosynthetic bacteria gathers around brine pools, attracting mussels and tube worms. The mussels and tube worms use the chemosynthetic bacteria to get their own nutrients in a symbiotic relationship, and because mussels are a source for food, other creatures come to feast on them, therefore developing an ecosystem all around the brine pools. These ecosystems are complicated and have a variety of animals that exist within them. Most notably, aside from the mussels and chemosynthetic bacteria, there's the hagfish. Eel-like in character, these fish have a skull but no vertebral column, and are the only living animal to have this characteristic. Other organisms that can be spotted living around the brine pools are shellfish like lobsters, large crabs, and shrimp. On the occasion, one might spot an octopus or a shark preying on the smaller animals. Now we know that these creatures live all around the brine pools, but what about inside of the salty water? We mentioned briefly how nearly nothing that dives into the pools comes back out due to the lack of oxygen, in a process known as toxic shock, but an even more unique occurrence happens as the animals slip in and die. They get pickled. The bodies of the animals become preserved and don't decay for centuries, and that's due to the barium sulfate that lines the inside of the pools. Gray in color, the sulfate precipitates out from the brine, meaning that any surface the brine touches, the sulfate will cover. However, there is an exception for what can go into the pools. Hagfish are known for burying themselves in anorexic mud, and so they have a special adaptation for surviving in oxygenless environments. Because of this, they can dive and resurface from the brine without being affected by toxic shock. Since brine pools are at the bottom of the sea, is there anything that threatens them? We know how human interactions with our oceans have easily put animals closer to the surface in danger, from pollution to overfishing. Has our intervention reached this far down? Surprisingly, no, or at least very little evidence of that exists at this current time. But the brine pools do face a danger, and that's in salt tectonics. As we mentioned, the sediment is cracking and shifting, which forms ridges for life to exist around the pools, but can also break the walls that keep the deadly waters contained. On the occasion, the walls of the brine pool will shift and collapse, allowing the brine to spill out like a waterfall. This is deadly to everything in its path, and is perhaps the #1 threat to life around the brine. As cool as brine pools are by themselves, the benefits of studying them make them even more fascinating. According to Scientific America, researchers found out that the sediment of the brine pools in the Red Sea contains information about the history of natural disasters from the surrounding areas. This would help us understand more about Earth's history and fluctuations in environment, and better predict these environmental phenomena in the modern day. But that's not all. Because the life that exists around the brine pools has developed from chemicals rather than sunlight, studying these pools may give us hints of how life may exist on other worlds, and in what types of conditions. If, say, there's a water planet, there may be life at the bottom of its ocean in a similar form to what we see around the brine pools. But perhaps most importantly, each brine pool has its own microbiology. Given that there are hundreds of brine pools in the Gulf of Mexico alone, and only 10 of them are receiving funds to be studied, that means there's a vast variety of bacteria with unknown effects. As of right now, we have discovered that some of the bacteria in the pools being studied have anti-cancer effects, which means that the brine pools may hold the answer to a cure for cancer. Brine pools provide an oasis of life in the deep seas, providing support for the ecosystems that surround them, and potentially hold the answers to some of our great burning questions. Because bacteria feasts on the chemicals released from the brine escaping into the ocean, life is able to form around the pools in abundance. From small mussels to daring hagfish to the giant crabs, they all rely on the life the bacteria brings to the area. These bacteria may also be the key to finding the cure to cancer, as well as solving how life may exist in other planets. But while we've learned a lot since the discovery of brine pools, there is still so much left to learn.